All right, so I need somebody to give me 2 supplementary angles. Anybody? Jenna.
5 and 6.
5 and 6. 5 and 6. Anybody else agree that 5 and 6 would be supplementary? 5 and 6, I would agree. So we would say 5, angle 5, and angle 6. Can somebody raise their hand and give me a second set? You go by Alexa, right? Lexi.
4 and 3.
4 and 3. Anybody else agree that 4 and 3? 4 and 3. What I would be writing about is supplementary angles, and I think if you have a definition of what supplementary angles are, that should be informative enough for you. You can follow along with this.
Okay.
It will sync with me. It might take a little second because of our internet, but it's up to you. Okay, so are there only 2 sets of supplementary angles here? There's lots of them, right? In fact, we could probably spend a lot of time finding supplementary angles here. Okay, there's definitely more than 2. Okay, same side interior angles. Can somebody tell me a set of same side interior angles? Lexi.
3 and 6.
3 and 6. Would anybody else agree with Lexi and say that 3 and 6 are same side interior angles? Yes? Okay, I'm seeing some eyes. Yeah. Angle 3 and angle 6 are same side interior angles. Okay, so if you didn't know what a same side interior angle is, what do you think that means? Same side.
Inside.
Okay, like the same side of which line are we talking about? The transversal. They're the same side of the transversal. And what do you think the interior part refers to? Inside of what?
Parallel lines.
Inside the parallel lines. Can somebody give me a statement about same side interior angles? Excuse me. Is there gosh, sorry, I'm stuttering. Is there a relationship between angle 3 and angle 6? There is.
Same side interior angles.
They are same side interior angles. So what do we know about same side interior angles? They are supplementary angles. Okay, so tell yourself somewhere in your notes that same side interior angles are supplementary. I'm going to say sup. Because I am a math teacher and I will abbreviate anytime I can.
Where the blank words would keep hot English.
That's right. Can somebody give me a second set of same side interior angles? Raise a hand. Let's see. Jenna?
4 and 5.
4 and 5. Anybody else agree with that? Agreed. Are there any more same side interior angles?
No.
No. There are only 2 sets. Did you notice that those 2 sets were also supplementary? So we could have also listed those angles up above on question number 1. Did you notice that? Supplementary. All right, number 3, I need a set of alternate interior angles. Alternate interior angles. Shout out, I guess, you're saying something, hold on. Autumn. 4 and 6. Would anybody agree with Autumn that 4 and 6 could be alternate interior angles? She is correct. 4 and 6 are alternate interior. Okay, give me a second set. Fallon. 3 and 5. Agreed. Yes, 3 and 5 are also alternate interior angles. Is there another set?
Yes.
No. No. There's only 2. Okay, also, what is the relationship between alternate interior angles? They are, go for it, Jenna.
They have the same.
Yeah, same measures. Does anybody know a really fancy word for same measure? Cool, there it is, congruent. Okay, congruent. Congruent is the word, and I'm going to say good, because I'm a math teacher. Congruent, congruent. Okay, congruent means they are the same. They are equal. Congruent. All right, corresponding angles. Who can see a set of corresponding angles? What? 2 and 6. Anybody want to agree with 2 and 6? Jump on board? No idea? Make an educated guess? 2 and 6 corresponding. You think they look kind of corresponding-ish? She is totally right. 2 and 6 are absolutely corresponding angles. Sorry, that was a bad angle symbol. 2 and 6. Can somebody give me another one? Fallon. 3 and 7 are corresponding angles. 3 and 7. Are there more than those 2 sets that I just listed? Yeah, how many sets are there? 4, right? Just 4. Not expajillion. In fact, that's not a number. Tell me something about corresponding angles. What's their relationship?
They correspond.
They're identical.
They are what?
Identical.
Identical. What's another word for identical in a geometry world? Congruent. They are congruent. Yes, congruent angles. They are the same. All right, number 5, a vertical angle. Who can tell me a set of vertical lines? Hold on, wait for it. Saray.
1 and 3.
What?
1 and 3.
1 and 3. Anybody want to jump on the Saray train? 1 and 3.
I don't really know what they are.
Vertical angles, making an educated guess.
Wait, yeah.
Saray is exactly right. 1 and 3.
2 and 4.
Oh, okay. Probably 2 and 4. Yes, 2 and 4. They're kind of like opposite, right?
Yeah.
They're like on the other side of that line. Can somebody give me a relationship between vertical angles? 1 and 3 are what kind?
They're supplementary.
Supplementary?
Complementary.
Whoa. Complementary. Ooh, good call. Okay, let's talk about the word complementary. What does complementary mean?
They complement each other.
No. Not in geometry.
But don't they add up to 90?
They add up to 90. Do you think that 1 and 3 add to 190?
I'm thinking now.
I'm thinking those are obtuse, and that's not even close.
190?
290.
Oh.
Do they add up to 90?
I never thought about it.
Oh, that's not good. Oh.
290?
Hey, maybe you were gone the day she taught it. I'm sure she taught it. Maybe you were sick that day or something.
Saying like over 2? Like.
2.
Wait, I feel
Oh,
so
do we need to write this out?
I literally
I'm glad there's people that can explain things to you.
Like you get like 290.
I understand. Okay, so we need to set it 2 angles that add up TO 90 degrees. Good there?
Sure. I mean, let's say I mean, why? I guess I'll just get it next time.
So, okay, so did we figure out a relationship between vertical angles yet? They are congruent. There's a word, yes. Vertical angles are, in fact, congruent. Okay, so what the heck does all this have to do with what we're learning today? Well, here we go. Okay, I'm going to skip this little statement part because we kind of just made a whole bunch of statements over here. I'm going to skip down to this part right here. Okay, so we're going to use the statements to draw a conclusion about same side interior angles. Okay, so we're talking about same side interior angles. Okay, so up above here, this statement, I'm going to just say this part right here. If we have 2 lines that are parallel, if we have two lines that are parallel, so I'm going to write if L and M, well, that was a really bad M, sorry. Let me try that again. M are parallel. It's clearly an M.
What about the last one?
Okay, then 6 and which angle is a same side interior angle with angle 6? Same side interior angle. Same side interior, angle 6. Angle 6 is 3. Okay, then they are, by definition, supplementary. All right, so we are now going to state the converse. Does anybody remember what converse is? Kind of like the opposite, right? So they kind of say it a little bit here on the top. So if we have if P then Q, then you just simply swap the P and the Q. So if Q then P. So if our previous statement was if the lines are parallel, then the angles are supplementary. So what's my converse statement? Right. So if the angles, specifically 6 and 3 are, you don't have to yet. I'll give you the definition here in a second. Supplementary, then L and M are parallel. Oops. Okay. Okay, let's do the same idea, but this time let's use alternate interior angles. Okay, so the theorem says if, what do we start with? If the lines are parallel, right? So if L is parallel to M, you see how I'm going to start making my little abbreviations because I'm a math person? Okay, then angle 4, is this a new symbol to anybody?
Yes.
This little wavy line with the equals, what does that mean? Congruent. Congruent. Okay, so they're congruent angles. So on our alternate interior, which one were we looking at? 4. Which one is alternate interior to angle 4?
6.
Angle 6. Good. So angle 4 is congruent to angle 6. So the converse of the statement would be if angle 4 is congruent to 6, then the lines are parallel. Oh yeah, now I got this. Now we're cruising. Okay, last statement, we're talking about corresponding angles. Corresponding angles. Okay, so originally, if, what is given to us? If they're parallel. Okay, so we're talking corresponding angles to 7. Back up here, 7. Which one corresponds to 7? Ooh, I heard some different numbers.
What does correspond?
Correspond, so like it's on the same
But
side,
it's not. That's.
right? Corresponding,
It
like,
could be any of those.
well, yeah, but they gave us 7. So
Yeah,
like if I said,
6.
what's corresponding to 5, what would you say? 1.
I don't know.
1. See it? Do you see the relationship?
Yeah, they're opposite.
Well,
Wait,
they're
so
like
they
on the
can't- they
same
can't
side.
Be, they can't be inside together.
Right.
But so like one's outside, one's inside, but they're corresponding.
Oh, I see, okay. So corresponding, so like if I kind of went like this and ignore this line for a second, just for a second, and I said, okay, there's angle 8. You see angle 8, how it's down in the bottom left hand?
Yeah.
Bottom left hand. Which one is in the bottom left hand of this one?
4.
4. They are corresponding.
So where it's located, it's like 7
Right.
on the bottom, right?
Yes.
So then it would be
3. There you go.
3.
There you go. Okay, so 7 was corresponding to 3, right? So converse of that is if angle 3 is congruent to angle 7, then L is parallel to M. Awesome. Okay, cool. You haven't written that down yet? You need to write down these 3 theorems. Okay, so that is the more official statement that I want you to write down.
Thank you.
Yeah, the first one is technically a postulate. Postulate, theorem, postulate. Do I know the difference? To be perfectly honest, no. So as you guys are writing this, are you understanding that we are actually talking about 6 different theorems? Okay, we have our original statements, which are, if the line is parallel, then blah, blah, blah about the angles. The converse is the opposite of that. Okay, so we're technically talking about 6 different theorems. Is everybody okay with that? Can you hear me as you are writing? So if you need to write the converse of the converse, which is technically the original, right? Then you need to write that down. If you can't remember, that's true. If the lines are parallel, then inside interior angles are supplementary. Yes.
So, the converse of the same side of your angles thing is, if the same side interior angles are supplementary, and if the lines are parallel, then the same side interior angle.
Exactly. Yes. Yes.
Why is one of them a postulate and the other two are?
Good question. I do not know the answer to that.
What does it mean? Does it mean the same thing now?
Yeah. So we're just going to pretend it's this theorem. And I'll do some research because I really don't know the answer to that. Postulates are treated as theorems. I think it's how they come up with them. So a theorem has been proven. A postulate might be a statement created from a previous theorem. But it's all we need to know is that it's a law, a theorem. Whoa. Oh. All right. So here is a real world example of putting these theorems into place, or maybe a postulate, depending on which one we're talking about. All right, so we have this designer, and she's using a quadrilateral shape, which, by the way, quadrilateral refers to four-sided figure. Okay, so it's pictured over there at the right, and she's making these colored tiles and making an ornamental design. So she's stacking them next to each other. Okay, so all of the tiles are congruent. And so we're going to make a statement about this, okay? So here is a picture of the tile. You guys see the little tile over there, the little quadrilateral? Can anyone make an observation about that quadrilateral? What? I'm sorry, what? Yep. That little... Okay, so sorry. This one right here. This right here. This little shape. This right here, this quadrilateral. What do you observe about it? Go ahead, Lexi. It's a parallelogram? How do you know?
Because the side, each side's parallel, so this side's parallel. How to explain it? I can't word it, but the sides are parallel to one another.
Okay, I'm not disagreeing, but I can't really say you're right because you got to give me a good reason. Jenna, can you help her out?
Well, I was going to say it's supplementary angles, but it's parallel. Oh, because if there's a pair of same side pair angles, the supplementary.
Ah, okay, same side. Now that wasn't the way I was thinking, but actually I can't disagree with your logic there. Say that one more time. Same side interior angles are
Supplementary.
so therefore,
The line.
very nice. I was not thinking of that way. Fallon, did you have a different thought? Because maybe you had the same thought I had.
I was just going to say the opposite angles.
That's what I saw too. Opposite angles also tells you that you have opposite angles tells you got a parallelogram, right? On a four-sided figure. Okay, but I really like Jenna's idea. Okay, so now we start stacking these things together, and I'm gonna kind of come down. I don't know really why they draw so many of these pictures, but let's draw this right here. Okay, so she gets out her little protractor and measures these angles. And who's her person? What's her name? Mosaic Designer. Miss Designer measures this angle 1 and says, this angle is 120. And angle 2 is 60. So what? What? Say it louder.
180.
What about 180? What do you mean? Where'd you get 180 from?
Don't they add them together?
You add them together and they make 180, which means they are
Supplementary.
supplementary. And what do you know about these two angles? What kind of angles are those? Same side interior angles. So if same side interior angles are supplementary, the lines are parallel. Conclusion. Boom. If same side interior angles are supplementary, the lines are parallel. Okay, so they are in fact parallel. By definition, same side interior angle postulate. You said theorem, I'd be okay with it. All right, let's try something a little different. Let's do some constructions. Okay, so what I want you guys to do